All right, this is pre-cal lecture 3.7. You will just need to get your 3.7 notes out, and we'll go through those. So it's about vertical and horizontal asymptotes. So a vertical asymptote is a vertical line that the graph of a function approaches but never touches. All right, so to find vertical asymptotes of a rational function, we want to cancel any common factors to put the fraction in lowest terms, set the denominator equal to 0, and solve for x. All right, well, when we talk about a rational function, remember we're talking about a fraction. So it's just a polynomial over a polynomial. And we're worried about, and to find vertical asymptotes, the denominator. Where's the denominator equal to 0? So in this section right here, we're gonna draw a graph of a sample vertical asymptote. And the way that you show an asymptote is just with a dash line. So let's say that this is at the point C. So this is our vertical asymptote, which I'll just abbreviate that as VA from now on. So maybe we have a function and it's rising, increasing, and it's trying to get to the vertical asymptote, but it just can never touch that. And maybe we have one like that that's coming from that way, but it just never touches that line. All right, so that's all a vertical asymptote is. It's a place that makes the function undefined, an x value. So we would say, in this particular case, we would say we have a vertical asymptote at x equals c. All right, that it could be 5, 10, 7, 2, whatever. All right, along the x-axis. All right, if you need to pause the video while you finish drawing this, go ahead and I'll move on down the notes. Okay, our first example from your notes is find the vertical asymptotes of p of x is equal to 3 over 2x minus 4. All right, so what you want to do is let's factor the denominator. We'll factor out a 2. You'd have x minus 2. And where is the denominator 0? Well, it's at 2. Okay, that'll make the denominator 0. So we have a vertical asymptote at x equals 2. And that's all we're doing. The next example, p of x is equal to 5 plus 3x over x squared plus 4x minus 5. All right, can't factor the numerator, so we'll just leave that. But let's factor the denominator. That'll tell us where our zeros are. So we have x, and then it would be plus 5 and minus 1. That'd give us a positive 4x in the middle. So we have vertical asymptotes at what two values of x would make the denominator 0? At x equals negative 5 and also at positive 1. Okay, our next example is f of x is equal to x squared minus 1 over x plus 1. Well, we can factor the numerator. That's the difference of two perfect squares. So we'd factor into x plus 1 times x minus 1 over x plus 1. Now the denominator cancels out, okay? And this just reduces down to x minus 1. So if the denominator cancels out, we don't have a vertical asymptote. We do have, though, a hole at x equals negative 1, but not, so you just have a little hole in the graph, okay, a little hole, but you don't have an asymptote if that particular x value can be canceled out. So no va is the answer. And our last example on the front page of the notes, f of x is equal to 9x minus 1 times x plus 3 over 2x plus 6 times x minus 5. Well, the only thing I could factor out a 2 on the bottom in this first term. So let's do that. 2, and then you'd have x plus 3, x minus 5. So that x plus 3 cancels out. So we don't have a vertical asymptote at negative 3. The x minus 5 doesn't cancel. All right? So our vertical asymptote occurs at x equals 5. We don't have an asymptote here at negative 3 because it canceled out. What we have is a hole. Now the question didn't say to find where the holes are. I'm just explaining to you what we've got there. All right, so that's the front page of your notes. Pause video if you need to, and we'll flip over to the back page of your notes. Okay, so if you have a vertical asymptote, you can also have horizontal asymptotes. So horizontal asymptote is a horizontal line that the graph of a function approaches but never touches. So let's draw an example of a horizontal asymptote in that space. So that's just a horizontal line. Let's say that crosses the y-axis at the point C. So let's say we have a function, it's descending, but it just can never get to that horizontal line. So this is a horizontal asymptote, which I will abbreviate as HA, and it occurs at y equals C. So crosses the y-axis at C. And of course, in functions, you can have multiple horizontal, multiple vertical asymptotes. All right, you figure out where the horizontal asymptotes are. It's really kind of pretty easy. You just really have to eyeball the function. So here are your 3 rules. You look at the fraction. It's always going to be a fraction if it has an asymptote. If the largest power of x is in the denominator, you have a horizontal asymptote at 0. Okay, I'm going to work an example of this in a minute, but largest power of x in the denominator. If the largest power of x is in the numerator, there's no horizontal asymptote. Okay, we'll have an example like that. If the powers of x, okay, when I say power, I mean like x squared, x cubed, whatever, or just x to the first. If the powers of x are equal in the numerator and denominator, then it does have a horizontal asymptote, and you use the coefficients to determine that. All right? So let's take a look at our 3 examples. Okay, the first one is we want to find the horizontal asymptote at f of x is equal to 3 over 2x minus 4. Well, there's no x in the numerator, all right? So the bottom wins. The bottom has the largest power of x, okay? We could say bottom wins. You can think of it that way, as a competition. So we have a horizontal asymptote at y equals 0. If the bottom wins, the horizontal asymptote is at 0. All right, let's say we have f of x. The second example is 4x cubed minus 3 over 2x plus 4. We just want to look at the largest powers. Okay, in the numerator, the largest power of x is x cubed. In the denominator, the largest power of x is just x. So the top wins. If the top wins, there is no horizontal asymptote. Now, if you take calculus, you'll find out why. We'll take the limit of this as x approaches infinity, but right now, y doesn't matter. You just need to be able to evaluate the function and determine where the asymptotes are. And our third example is f of x is equal to 9x minus 3x squared over 7x squared plus 103. We only care about the largest power of x. So the largest power of x in the numerator is x squared. The largest power of x in the denominator is also x squared. So I don't care about the 103. I don't care about the 9x. Now, if it's a tie, you have to think about the coefficients. So we have negative 3x squared, and we have a 7 here. If it's a tie, the horizontal asymptote is determined by the coefficient. So our horizontal asymptote occurs at y is equal to negative 3 over 7. See, it's like these x squareds cancel out, right? So negative 3 over 7. So that's your three possibilities: a horizontal asymptote at 0, no horizontal asymptote, or a horizontal asymptote that occurs that you determine through the coefficients when the powers are a tie. Okay? So that is, it's a very simple lecture. That's lecture 3.7. If you're watching this in 2020, okay, you're watching this in 2020, this homework 3.7 is due on Wednesday. If we are at school, bring it with you on Wednesday. We'll go over it. Okay? If we are not at school, you will need to scan it in with Genius Scan and email it to me, or you can upload it on Microsoft Teams into the assignment section. All right, so that does it for Pre-Cal Lecture 3.7, and I'll talk to you next lecture.